Test 1 2 1 2 test. That was a stretch. I'm not putting that in there. Hello, it is me. You would notice that I am not a PNG at the moment. I'm trying out some face tracking stuff, using VR chat and the whatever public models are available that support face tracking, which is why you can see like I have face tracking and stuff. The problem with that is that there's very limited number of avatars that have face tracking, right? And then the ones that do are mostly like 98% of them are female, and the few that are male, they're like semi-chibi, kind of like this one, or overly sexualized e-boys. So I found this one kind of like a little like Oni demon-esque ish little guy. I was like, okay, we'll go with this. I wanted to do some React stuff today, so we're gonna react to the new Unreal Engine 5.6 stuff. I didn't even look to see how long this video is. It's 12 minutes. That's not too bad. So we'll go through this. We'll see what's coming in 5.6. I saw that there was like a tech demo for The Witcher. So I imagine that's probably what's in this, because I've seen that everywhere. I haven't seen it, but I've seen it everywhere.
Version 5.6 just released, and it is a huge deal. The main reason is the new Metahuman creator. Around the time UE5 released, it introduced Metahumans, which is a framework that gives creators the ability to create and animate realistic humans.
I tried
It
this.
is a collection of tools and standards that makes the human creation process significantly easier. Most new Unreal games, like Clair Obscur Expedition 33 and the Oblivion remaster, are using Metahuman.
You cannot tell me that Oblivion is using the Metahuman. That you believe it? I hate Oblivion characters. They're so fucking ugly. I mean, it's my personal preference, right? But
Metahumans. The easiest way to create a metahuman was through the online metahuman creator. The problem is that we were severely limited in customization options.
Yep.
There was only 6 body types to choose from, and a small amount of clothing options. While we could export the metahuman to Blender or Maya for further customization, you had to be an advanced 3D artist to do so. Also, the creator was hosted on a website, which meant it was slow if you had a bad internet connection, and you had to wait for the metahuman to download. Now in 5.6, we have a brand new metahuman creator that is directly in Unreal, with significantly more customization.
Oh, nice.
You can now create a metahuman like any other asset in Unreal. The biggest new feature is body customization. Now we have a bunch of options to change the body of our metahuman, giving us complete control over all parts of the character. Now you also have the option to turn objects that you made in Blender or Maya into metahumans with the Conform tool. So you can make exactly what you want as long as your mesh is using the metahuman geometry. All you have to do is select your custom metahuman mesh and conform it. You do this for the body and the face. Now here we have an insanely muscular metahuman. This allows for stylized and unique characters. And just like the Elder Scrolls Oblivion, you can create some pretty interesting looking characters. Truly now, the possibilities are endless. Another part of the metahuman framework that was improved is clothing. Previously, the standard way for metahumans to get clothes was by adding them as an extra mesh. These clothes were just geometry, using the same bones as the metahuman. So, when the metahuman bone rotates, so too will the clothing on top of the human. But clothes do not move uniformly like that. You would expect it to move around the metahuman's geometry with creases, folds, and draping, just like how cloth works in real life. Now there's a new outfit asset that leverages Chaos Cloth. Chaos Cloth was introduced in previous versions of Unreal, with the goal to replace using skeletal meshes as clothes with true cloth simulation. In this example, there is a cape on the back of this character. As she walks around, the cape is interacting with the body and environment realistically, adding a new level of immersion. If you have an outfit, applying it to your metahuman in the new creator is as easy as selecting it. The cloth will automatically resize itself when we change the metahuman's body.
That's pretty big. uh, I mean, in VR chat, you could make cloth meshes and have it like drape over geometry and stuff, and you would just pin or anchor certain points so that it would move around the character, right? But not like fall through the character. And this is Unity, right? It's been around for the ability to do this has been around for a long time in Unity, but not to this standard of quality. This looks a lot better.
Body. The next new feature is live facial animation with cameras. Unreal already comes with a great facial animation tool called Metahuman Animator. It allows you to turn videos into high quality facial animation using machine learning. But there are two downsides. You need to have either an iPhone or an expensive motion capture camera, and it is not real time.
Yeah, but
We have
like
to
everybody
process the
has an
video
iPhone.
data before we can see the animation. An alternative is to use AR Face Kit. It is using the same technology behind Memojis to animate the face in real time, so any facial movement you make in real life happens automatically in engine. But
That's what I'm using right now, actually. So I have an iPhone set up using AR Face Kit, uh, and it's tracking the. I mean, there's only like a few parameters right on this avatar. It's through what's called VRC FT or VRC face tracking. There's only like 100 parameters or something like that, so it's not a lot. Again, something that's been in Unity for a while that you could do. But carry on.
it also requires an iPhone, and the quality isn't that good. Now in 5.6, Metahuman Animator was updated to support real-time facial animation that
It looks
allows you to
clean.
create live face
It looks a little
animations
weird,
with
but it
just a
also looks
normal
clean.
camera. So you could use an Android or even a cheap webcam. You no longer need an iPhone to get this amazing feature. I'm capturing this face animation with just my webcam. Everything is live directly in the editor, and the quality is amazing. This is made possible by AI that was trained on 5 petabytes of facial movement data. And
That's a
you can
lot of
still
data.
process the regular videos for better quality and tongue movement. In addition to live animation, we now have real time audio driven animation. The last version of Unreal introduced a new tool that also uses AI to create realistic animations just from audio, with no camera involved. But this had to be processed.
Okay, so not to like keep beating the dead horse and saying like, oh, you know, Unity has had this, but literally VR chat has been using we call it's Visemes, so it's audio driven facial or mouth movements. So based on like ooh ah e o, it moves the mouth a certain way. Now I'm not using that right now because again I'm using the AR kit, but uh, Unity's done this for a while. Now it seems that Unreal's MetaHuman one so far looks pretty good. I'd have to see or hear rather audio coming through that's in time with the mouth animations to see like how accurate it is because like you know Unity would Unity yeah I'm starting to like get mixed up Unity and Unreal. Unity's been doing it for a while, right? But it limited amount of Visemes, whereas it looks like MetaHuman might be able to or Unreal might be able to do more sounds. So
Now, this audio animation can also be done in real time. What you're looking at right now is face animations from me speaking into the microphone live. This can be a lifesaver
that's not
for
bad.
video games that have thousands of hours of dialogue, like an RPG. A new feature was introduced in 5.5, but has a more stable release in 5.6, and that is Nanite characters. To briefly sum up Nanite, every object you see in computer graphics is made up of tiny flat planes of geometry called polygons.
Yep.
The more polygons on screen, the longer it will take to render.
Yep.
This is why video games use LODs, which is short for level of detail.
Yep.
The further away an object is from the camera, the less polygons it will use to render that object. This makes games run faster, but we are limited in the amount of geometric detail we can have. Nanite fixes this because it uses dynamic level of detail, which means you can have an object with millions of polygons without any LODs, because the geometry is dynamically changing. A good example of nanite in use is this jungle. This is nanite in action. Every color is an individual polygon, and there are millions of them. When nanite released, the biggest issue is that it only worked on non-moving static objects, like your rocks and buildings. This changed when the UE 5.1 update introduced nanite foliage, which gave us the ability to create forests with an unlimited amount of detail. Here's a
That's
world with
crazy.
over 100,000 trees, without any LODs. Each leaf you see is made up of real polygons. And then in UE 5.3, we got support for nanite displacement and landscapes. This gave us the ability to sculpt nanite geometry directly onto our objects and landscapes. We can now create high quality geometric detail from height textures and blend them together, giving us more creative possibilities. The ground of this forest is driven by nanite. Besides the foliage, all of the rocks, dirt, and twigs are one continuous object being handled by height textures. All of this allows for the entire geometry of an environment to leverage nanite, allowing for worlds like this, which have millions upon millions of source polygons without any level of detail popping. But one of the core features of any game or animations was still missing nanite, and that was characters. In Unreal, characters are called skeletal meshes.
Mhm.
A skeletal mesh is just like your normal static mesh, which is the geometry. But it now has a skeleton, which are the bones of your character. Each of these bones function like how they do in real life. When a bone rotates, a part of the object associated with that bone will rotate with it. This is what every character in a game is
Whatever's
made
weight
up of.
painted
And
to those
just like with
bones.
normal static meshes, skeletal meshes have a lot of the same drawbacks. We are limited to how much geometric detail is on a character. Skeletal meshes with millions of polygons do not perform well.
Well, okay, so and the way that this was worked around was you'd have a mesh, right, that was topologized in a certain way so that you'd have uh fewer polygons, right? An optimized amount of polygons, and then you'd put a height map or bump map and a normal map, an occlusion map, and all these other textures uh, on top of that to give it depth and realism, and then uh, your texturing, obviously the way you color and paint it and stuff also helped, and then you would take all those textures. Hopefully, you'd put them in an atlas, which is just one giant texture that is like split up. You put the UV map is placed on top of that. But if you could do that in an efficient way, um, it would look almost indistinguishable from like just something that's high topology that's like thousands and thousands of polygons for something that should only take a few hundred, right? So it's really about just people being lazy now and not wanting to optimize. We want all these polygons and da da da. No. While it's great that the engine can do that, like how about we also take time to uh, make performant meshes and objects for our games?
This is why we fake detail with normal map textures. Essentially, normal maps create the illusion of small detail
Yeah,
by adding in fake shadows.
yeah,
Here we have a simple character that is looking pretty flat, and as soon as we add in a normal map, then we will get a bunch of fake shadows.
and if you put this model up next to a model that looks almost just like it, right? But it is more topology. You wouldn't, especially like in a game environment, you wouldn't really be able to tell the difference between the two of them. With them being static and next to each other, if there was another one that was like high topology next to it, you'd be able to tell like around the edges where like you can see like some of this look. You can almost kind of see the polygon, the topology. It's a little edgy. It would be more round, right? You'd have some better spots. But in a game environment when things are going on and stuff is moving, like you don't need millions of polygons to represent a skeletal mesh.
Making it look like there's more geometry than there actually is. But creating characters where the majority of detail is being handled by normals can make the 3D modeling and texturing process harder. Not to mention, for
Why? Because you have to actually do your job and optimize for the game that you're building.
performance, you still need LODs.
This is true. You need LEDs. You do need to create the optimized versions, right?
So each character needs to be remade multiple times with less polygons. 5.5 gave us nanite skeletal meshes, and 5.6 makes it more stable and usable. In this world, I have multiple dragons, each with over 700,000 polygons, and my game is chugging along. With just one click, I can enable nanite on the character, and we get back to a smooth frame rate. Zooming in, we can see how each scale is real geometry. They are not being faked by normal maps. From the teeth to the spikes on its back, it is all one character with hundreds of thousands of polygons.
Which is 100% unnecessary.
Now, for the first time, everything in your world, whether that be the foliage, the landscape, or characters, can all leverage nanite technology. Do you need a character with millions of polygons for a video game? No. The odds of a player zooming in on a creature to notice this detail is pretty low. Not to mention, there's still
Uh, not to mention before his, not to mention this dragon looks like ass. It looks like a plastic toy. That type of geometry, like the scales and stuff on his back, easily replicated by a normal map.
still a performance cost to having this many polygons on a character, and the size of your game will increase because it has to store all of these polygons. But if you have a character with a normal amount of polygons, it will help performance by enabling nanite, if the rest of your world is already nanite. There is no sponsor for this video, but if you like it, make sure to subscribe for more Unreal videos in the future. With every update, we get major graphical and performance improvements. We now have physically accurate reflections on glass and water with the new translucent ray tracing.
That's
Ray
nice.
trace glass and water materials would often glitch out, and glass could not render when seen through another glass material. In 5.6, with the new ray tracing translucency, all of those issues are fixed, and we get access to realistic refractions without path tracing. A common problem in first person games is that the first person model is rendered with the world. So if we come up to a wall, the gun will clip through it, breaking immersion. This is now fixed with first person rendering. It allows us to render the first person model separately from the world, eliminating clipping.
Yeah, but that gets rid of your sense of depth because okay, this might be a little bit of a rant. When you put your face against a wall and the gun clips through it, you get a better sense of depth because you feel like you can judge the distance between you and where you are, right? And then like this, now what first felt like you were up against the wall, now it feels like you've pushed yourself further back and then the wall has gotten bigger or stretched. It doesn't feel right. What they should do is implement a text so that when you get close to a wall or an object like this, if the end of your gun touches the wall, it pushes back into your character. Like it would if you were to put your face against the wall, you would put the gun, like if you had the end of the gun against the wall and you put your face up closer to the wall, obviously you can't push the gun through the wall, so it would come back further closer to your body. That's what I think they should do.
Epic Games has begun the process of allowing the rendering thread to use multiple CPU cores. In the past, this rendering has only been done on one CPU thread, which can lead to stuttering. Utilizing multiple threads paired with pre-caching shaders before gameplay, we can expect stuttering to be greatly reduced. Rendering across the board continues to be optimized. In complex environments that use hardware ray tracing, there's an extra 10 to 20 frames per second when comparing UE 5.5 to 5.6. We get even more improvements to Unreal's animation tool called Sequencer. Animation got a lot easier with motion trails, which are lines in the viewport that shows the timing and movement of your animations. This makes adjusting and visualizing your animations a lot faster. We can now sculpt morph shapes. Morph shapes allow you to store and animate different shapes of a mesh. A big use for them is to store poses for face animations.
Blend
But if you
shapes.
want to make a change, that had to be done in Blender or Maya.
Yeah, so in Blender you can make these things to the mesh called blend shapes, and then you can animate them later. So again, this is something that we've been doing in Unity for VR chat to make like do I have any face animations? So you can see I can see like my eyebrows move. Those are blend shapes. I don't have all of it on because the face tracking is taking over like most of the control of the face. But it would probably do like different faces, like probably like a oh or like a smile or something. So
Till now. In 5.6, I can sculpt a morph shape representing a dent in this van. Now in Sequencer, I can animate the car transitioning to the dent. So when a character hits the van, it now leaves a mark. A unique feature is the rig locomotor. What this allows you to do is procedurally create walking without any animation. Unreal is creating this entire animation on the fly. This can be great for complicated creatures like a spider or background characters. The most obvious difference for current Unreal users is a brand new viewport interface. Since UE4, the viewport options were shaped like bubbles. Now we get a more common, flat look. The buttons are still the same, just they were moved around. Unreal is democratizing 3D creation. It allowed Sandfall Interactive, a small studio with a core team of just 30 people, to create a critically acclaimed game like Clair Obscur Expedition 33. It initially started as a small project in Unreal Engine 4 using templates. They then transitioned to UE5 so they could leverage all of its new features.
and boy, let me tell you, did they copy paste like crazy. They had this asset in the very beginning of the game when you are Gustav and you're just going across the rooftops, like in the very beginning. Uh, they have so many different things that are just copy pasted everywhere, like the smokestacks on the top of the roof, the vent stacks or whatever. God, those that's the most atrocious thing. It's literally everywhere. The there's like these boxes that are pretty much copy pasted. These like plant trellis things, multiple other things. Just look, just go back and play. Look at all the different little items and see how much of it's just like copy pasted across the rooftops and how much clipping there is. There's a lot of stuff that's clipping really bad. So you could tell that they just took these items and just slapped them on top of the roof and they said, looks good enough. Still a great game, an amazing game. They just did a lot of copy and pasting.
Like Lumen, Nanite, Metahumans, and more. It has never been easier to create stunning, high quality games than before. Luckily for you, I have 2 free courses right here on YouTube that will teach you
Wow.
the basics of Unreal. In the first beginner course, you will learn how to create this castle environment you see right now. And in the second tutorial, you will program your first video game. You can check out both of them, links in the description below.
Hey, yeah, that's pretty cool. Go check out it's Unreal Sensei. Uh, Go check out his. If you watch this video, you like his video, you like his content, you want to learn how to do stuff in Unreal. I guess go check out his stuff. See what he do, but also check out other tutorials too. You know, just make sure you're covering all your bases and you're learning everything from everywhere that you can.